Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for lesson 3.2.2. Here we get into the process for subtracting integers, okay? So this is, the KFC. That is a very important strategy to use. Very, very helpful, especially when you don't want to draw all of these integer sort of tiles. So if you take this example, -3 minus a -2, this actually isn't a very difficult one to draw. It's pretty logical, really, because it says you start with 3 negatives and you take away 2 negatives. So how many negatives do you have left over? 1 negative, right? If you were to actually talk through this expression the way I just did, this would not be a very difficult problem. This would be kind of like just adding 2 numbers together or subtracting just basic numbers. But it looks complicated. So if we did KFC instead and kept the -3, but instead of subtracting a -2, if we added a +2, now we go back to our rules for adding integers together, where you take 3 negatives, 1, 2, 3, and 2 positives, find the 0 pairs, and you're left with -1. So either one of those works just fine. But this one, you kind of had to do a little mental exercise to think about -3 take away -2, whereas here it seemed a little bit more intuitive. Here's where it starts to become a problem. Starting with 5 negatives, and you're going to take away 2. Well, you don't have any positives to take away from this. So this is where it really starts to get complicated. But not only can you take away 0 pairs because they're 0 and they get married and they go off and have their honeymoon, but you can also add 0 to number and it won't change its value. This is literally saying 5 plus 0 again, which we know is equal to 5. So if we add 2 0 pairs to -5, you will now have enough positives to take away, and that leaves you with 7 negatives as your answer. All right, let's do KFC now and show how that would work. Instead of taking -5 and subtracting 2 away from it, which seems impossible, which is not when you manipulate it this way, but it seems impossible, let's try taking your -5 and flipping that to a positive and then changing the 2 to its opposite. And now you've got 5 negatives and you're going to add 2 negatives to that 5 to give you a total of 7 negatives. That makes more sense. And so that's why I am a huge fan of changing all subtraction problems to addition problems by adding the opposite. In other words, using KFC. Example number 3, starting with 3, and you're going to take away 3 negatives. Well, I don't have 3 negatives. How can I take away 3 negatives from 3 if I don't have any negatives? So enter the 0 pairs. If I add 3 plus 0 plus 0 plus 0, I still have 3. But now I've got 3 negatives that I can take away. So how many positives are left over? 6 positives. So the answer to this problem is +6. That seems confusing. So let's use KFC instead. Keep 3 as it is. Flip that to its opposite sign, so change it, or flip it from a negative, or I'm sorry, from a minus to an addition sign, and then change the -3 to its opposite, which is +3, and you get 6 for an answer, and that seems a lot easier than working through this process. Although it's good for you to understand this process and see why we get the answer that we get, but just using KFC and manipulating these expressions makes your job a lot easier. All right, so 5 minus 7 would be the same as 5 plus a -7. And since you got 5 positives and 7 negatives, you've got more negatives than positives, which means you're going to be left with 2 negatives once you find the 0 pairs. So when you're adding 2 numbers with different signs, you'll do a subtraction and keep the sign of the bigger number. 7 has a larger absolute value than 5, so you're going to keep your negatives. But as I like to say, you've got more negatives than positives, so you're going to have negatives left over. Here, -5 plus -7 all negatives. So just put them all together and you got a total of 12 negatives there. You're adding two numbers that have the same sign. You're going to add the numbers and you're going to keep the sign. Here you've got more positives than negatives. How many more positives do you have? Two more positives than negatives. So your answer is going to be positive 2. And here you're starting with -5 and you try and take away 7 negatives, but you don't have enough negatives to take away 7 negatives. So let's not just add the 0 pairs. Let's just do KFC. -5 minus a -7 is the same as -5 plus a +7. And now you can model it. You've got more positives than negatives. So you end up with +2 as your answer. And in fact, it becomes the same problem that we had there. So these two are exactly the same problem. They give you the exact same answer. Rewrite each expression using only addition. So remember, this is a review of the fact that multiplication is repeated addition. So if it's 5 times -2, that means you had 2 negatives plus 2 negatives plus 2 negatives plus 2 negatives plus 2 negatives minus 3. And I'm going to do a little KFC here. And instead of having this be -10 minus 3, change it to -10 plus a -3, which is how we get -13 for our answer. Here, I don't like these problems. I'm sorry, I really am. This is not a lot of fun to work through, especially this one. Why give us something like that? That's just a mess. These make a little bit more sense, like 4 groupings of -25, and the fact that you are going to repeatedly subtracting a -25 is the same as repeatedly adding a +25 4 times. So that's what I did there. I just hope you get the answers right. Okay, do the multiplication first, then 7.69 plus a -10 ends up giving you -2.31. I want to move on. If you got those answers, great. If you didn't and you really want me to work these out in more detail, I guess that one sort of makes sense, right? Instead of -3 minus a -5 plus a +5, so you end up with -10 plus 5 is -5. That one's not too bad. Hopefully, when you look and see how I expanded those out, you see how I got the answers. All right, and these diagrams, I love them so much. This right here is a model for the problem 3n plus 10 is the same as 28, right? They're both tight ropes. They're the same length, right? They start in the same location, they end in the same location. So they have to be equal in length, which means this expression on the top is equal to that expression on the bottom. So this is a perfect model for explaining why we do what we do when we solve equations. The first thing I would do is get rid of this 10 right there, which means I'm going to take away 10 of the 28, which leaves me with 3 n's is now equal to 18. And so if each one of those is the same length and they add up to 18, that means that each one of them has to be 6. So that means that n, wait, what, where? What? Wait, hold on. I am so confused here. Why do I say 7? Shouldn't that be 6? I think I made a mistake there. I'm crossing that out. The answer is supposed to be 6 feet. Each one of those is 6 feet. Oh, I know what I did. There was one year when I had some students who didn't always pay attention to what I was teaching, so I would purposely put up wrong answers to see if anyone would catch it. And so that's what this is. It's not nearly as effective when you're looking at this online on a video and you're not in my classroom to raise your hand and say, hey, wait a minute, I see a mistake. That's what I do periodically. And so I leave that in there. I'm not going to fix that because next year I want the same students or my students next year to catch this mistake as well. Okay, so what do we have here? We've got 2x's is equal to 7, right? Each x has to be half of 7, right? Because we're cutting 7 in half. So this must be 3.5 and this must be 3.5 if the total is equal to 7. And these two are equal to each other, right? Because x has to be the same as that x. So that's how we get x is equal to 3.5. Oh, and by the way, showing this process algebraically would involve us dividing each side by 2. So x has to be 7 divided by 2, which is 3.5, or 3.5. All right, and now adding or subtracting fractions. When we've got a common denominator, life is good. All we have to do is take the numerators. 11 minus 7 is 4. 4/12 can be simplified down to 1/3 because they have 4 in common. 4 divided by 4 is 1. 12 divided by 4 is 3. Using the coat of arms only works when you're adding two numbers together. So in a situation like this, you really are better off finding the common denominator and rewriting these fractions as equivalent fractions. And in this case, 8 is the magic number because 4 times 2 is 8 and 2 times 4 is 8. So if we multiply 1/2 times 4 over 4 and 3/4 times 2 over 2, now we can add straight across and get 11 over 8, which is in simplest form, but it could also be written as 1 3/8. And then here, if you want to do the coat of arms, you can. You could get 18 over 24 minus 4 over 24, in which case you would get 14 over 24. But that must be simplified. So when you divide the top and the bottom by 2, you get 7 over 12. If you found a common denominator that was the least common denominator, that denominator would be 12. So we'd multiply 3/4 times 3 over 3 to give us 9/12, and 1/6 times 2 over 2 to give you 2/12. And now go straight across. 9 minus 2 is 7. That was the same answer we got below. So either way works just fine. And now, sketch the rectangle at the right. Calculate the perimeter and area for the given values. All right, so the expression for perimeter is you add up all the sides, right? And so the perimeter here would have to be 3 plus 3 plus x plus x. So the expression for perimeter in all of these is going to be 2x plus 6. So 5 times 2 is 10, so the perimeter for the first one is going to have to be 10 plus 6 is 16. Now, I wrote these because those are the generic formulas for perimeter and area of rectangles, but we are dealing with some knowns and unknowns, so I'm going to choose this as my formula here. For area, it's base times height, which should be 3x, so in this case, it's 3 times 5 is 15. For problem B, the perimeter is going to be 2 times 9, which is 18, plus 6 is 24. And then 9 times 3 is 27, so it's going to be 27 square units. And then part C is going to be the most tricky because 3 times 4.6, we have to figure that out. Oh, wait, is it 3? No. For perimeter, it's 2 times 4.6 plus 6, so that's going to end up being 9.2 plus 6 is 15.2. And then 4.6 times 3 is 13.8. So whether or not you chose to use the generic formula and then plug these numbers in here and then plug them in, or use the algebraic expressions for the literal perimeter if we didn't know that number, or the literal area, either way works fine. And that ends our homework for today. Let's move on to the next task. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood.